Alright, today's topic is about radical expressions with variables. So on a previous topic we talked about radical expressions and breaking down numbers that are not perfect squares into numbers that do have perfect squares and breaking them up in that way. In this case, for today's lesson, we're going to be doing the same thing, but now we're going to add in some variables with it, okay? So, an important rule to remember involves x squared, okay? So if we take the square root of x squared, this equals x, okay? Which makes sense because what does x squared equal? Well, x squared is this x times x, right? X times x equals x squared. So x is the same number, right? They're both x, so it's basically a number that multiplied by itself gets us its squared, okay? So vice versa, the square root of x squared equals x, okay? So that's how this whole works out, okay? Don't worry if you're confused, it's okay. Let me make it a lot simpler for you in a second. So we know that x squared, the square root of x squared equals x. Now, let's say you have bigger numbers, okay? Basically what you want to do is you're going to be doing the same thing and breaking it down into two separate factors. So, for example, let's say we have, if we do it with x squared, okay, let's just keep it simple because we know this, x squared. We know that x squared breaks down into the square root of x times the square root of x, right? That times that, right, equals that. And then, as I said in the previous video, we know that anything times itself that are the same number with a radical just equals that, okay? So same thing here. So this breaks down just into this symbol x, okay? I know letters are confusing. Okay, they're not that confusing, but I know some of you can get hung up on this. So another way to think about this, and it's gonna make a lot of sense in just a few seconds, is basically whatever. Well, I'll get to that. Okay. So what happens if you have x to the third power? Okay. So clearly you can't square root the 3 there. Okay. So what does this mean? Well, we know that this, x to the third, this equals x times x times x, right? There's 3 x's, that's why it's a third there, okay? So that's how we know that works there. So how do we break this down into what we can break it down into with radicals? Well, let's take our x3. We know we need 2 things that multiply to get x to the third, right? Well, remember, when we're multiplying variables with exponents, remember we just add the exponents, okay? So we know that x, let's just, for example, side note, x squared times x to the fourth. Remember, you keep the base and add the exponents. 2 plus 4 is 6, okay? This is going to be very important. X to the third times x to the 7th equals x to the 10th, right? Keep the base, keep your letter, add the exponents, okay? So that's how we get those numbers, right? So, side note over. So when we talk about this, okay, we basically need numbers that can add to 3, okay? In this case, we know that 2 and 1, essentially, right? Remember, x to the first is x by itself, okay? So we can break this down to x squared times x, because x squared times x equals x to the third, because we're adding the exponents, right? Well, we know that x squared, the square root of x squared equals x. So this can break down into x. But this x here, it's by itself with the square root, just like we did in the previous video. So we just bring that down to equal that, okay? I know, bear with me, it's okay. I know, bear with me. It's not as hard as it seems, okay? So, once again, taking a number, breaking it down into numbers that we can, into 2 different things here. Now, here's the very important part. The higher you go, okay, if you have an even your exponent is even, okay? So let's say any of your exponents are even. Let's say 4, okay? All you're going to do to figure this out, if you have an even exponent, is to divide your exponent by 2, okay? So we take away a radical, and 4 divided by 2 is 2. And that's our answer, x squared, okay? That's our answer because x squared times x squared equals x to the 4th, right? So both these two are the same thing, right? Multiplied by each other, you get x to the 4th, okay? So any number, any variable in which you have an even number, divide that number by 2, take the radical out, that's your answer. So, you know, x to the 6th square root. Divide your 6 by 2, you get x to the 3rd. You know, the square root of x to the 12th. Divide your 12 by 2, x to the 6th. Okay, so very important to remember. Anytime you have a variable with an even exponent, just divide that exponent by 2 to get your answer, and take away the radical. Divide 6 by 2 to get 3. Divide 12 by 2 to get 6. Okay. Now, what if you have an odd number? Let's say x to the 5th. You're trying to do the square root of x to the 5th. Okay. If you have an odd number, we need to make it even. So what we're going to do to work this out, we're going to break this down just like this. Okay. Subtract 1 from your number. Okay. So we're going to subtract 1 from 5 to get 4, and that way we have our x by itself here. Okay. So anytime you have this, and then we know that our square root of x to the 4th, we know, divide it by 2, x2, and that stays where it is. Okay. So odd number exponents. Take 1 away from it. Break it down into that. So we know 5 minus 1 is 4. Bring your other x over here. By itself underneath the radical, and that's going to stay underneath the radical by itself. And then you're going to go ahead and divide your exponent by 2 to get 2 here. Okay. Same thing. X to the 9th square root. Okay, odd number, right? Odd number here. Take 1 away from it. You take 1 away, you have x to the 8th, right? And then your x by over here by itself. And then take your 8. Now it's even. Divide your 8 by 2 to get x to the 4th with no radical. And then you have your x by itself underneath the radical next to it. Okay? So that's what we're talking about here. Okay, this is just simple things we got to talk about. One more quick example of this before we move on. X to the 21st square root. Take 1 away from 21 to get x. Take x to the 20, and then your x by itself over here. Sorry. Okay. Take 20, divide by 2. X to the 10, no radical. Next to your x with the radical. Okay. So, even number variable, or sorry, exponent with a variable, divide by 2. Odd number, take 1 away from it, divide by 2, and then your other one stays underneath the radical by itself. Okay. So, let's put some numbers to it. Let's do 63 x squared. So the square root of 63 x squared. So in this case, when you have numbers and variables, you want to break those into separate pieces, okay? So let's break this down first into number, 63, the square root of 63, and variables, the square root of x squared, okay? So we're going to break those ones first, all keeping the radical above it, okay? We're all underneath the radical first, okay? So we broke our numbers up and the variables up into 2 different pieces. Work with the numbers. So once again, we need 2 numbers, factors of 63, multiply that 63, in which one of those numbers is a perfect square. So in this case, we know 9 and 7. 9 times 7 equals 63. So we know the square root of 9 is 3, and the square root of 7 comes down by itself, right? Now, so we're done with this, with the number part. Now to our variable, we have x squared. Remember, the square root of x squared is x, so the square root of x squared is x. Okay. Now we need to put it all together as an answer. Okay. So in this case, when we get to this part, when you put together your final answer, basically everything that's on the outside, or basically that doesn't have a square root symbol or a radical, goes on the outside. Everything that does have one goes on the inside. So, for example, what does not have a square root symbol? Our 3 and our x. So they're going to go next to each other on the outside. Now underneath the square root symbol, what do we have? We have 7. 7 stays underneath the square root symbol, and that's what we're going to have as our final answer. Okay? That's going to be our final answer. So that's how we get to where we get, right? Break your numbers and variables into two pieces, numbers, variables. Start with numbers, break it down. 9 times 7 is 63. Square root of 9 is 3. Square root of 7 stays the way it is. Over to your variables. Square root of x squared, we have up here is x. Break it down, x here. And then put your numbers that do not have a variable, do not have a radical. 3 and x go on the outside. The 7 with the radical stays underneath it as such. Okay. Let's do another one. Let's do the square root of 50 x to the 6th. Okay. So now, same thing, right? Let's split it up into numbers and variables. So we have 50 square root and x to the 6th square root. Okay. So start with the numbers. Two numbers that multiply to 50, in which one of those numbers is a perfect square. Let's use 25 and 2, because 25 times 2 is 50. So we take our 25. We know square root of 25 is 5. Our square root of 2 comes down as such. Now, to our letters here, our variable, x to the 6th, look at the exponent. Our exponent is a even exponent, which means we can just take this 6 and divide it by 2. So 6 divided by 2 gets us 3. So our answer is x to the 3rd for this part here. Okay, we're done with this. Now to put it all together. So which ones do not have a square root symbol? Our 5 and our x to the 3rd, so they go next to each other on the outside, and then underneath the square root by itself is 2. And that's our final answer there. The more you do this, the easier it gets, the more of a hanger that you're going to make. Okay? Let's do one more. Let's do the square root of 27 x to the 9th. Okay? So, once again, break it down. Numbers, letters. Okay? 27. Two numbers that multiply 27, and which one of those is a perfect square? We have 9 and 3. We know the square root of 9 is 3, and our 3 square root comes down next to it. Okay, so we're done here. Now let's go to our variable. Look at the number, our exponent. We have an odd exponent, which means this has to break down into, remember, we're going to take 1 away from 9 to get 8 here, and then our x by itself on this side. Now we have our even exponent here, so go ahead and divide this by 2 to get x to the 4th. Bring down our x and the radical here. Okay, so now this one's done. So now we're done with separately. Now we combine them. Everything outside of the radical. Okay, we have 3 and x to the 4th. So we have 3 x to the 4th next to each other here, and our radical. Now what's underneath the radical? 3 and x. So we're going to put them together underneath the radical there, and we have our final answer. Okay, so I know it can be kind of confusing. You're adding letters and numbers again. I know how much you guys love doing that, But as with all math, the more you do it, the more practice you get, the better you get at it, and the easier it becomes. Okay, so just remember, don't split it up. Numbers, letters. Work the numbers first, then work your letters, and then at the end we're going to put them together here. Okay.